In a previous tutorial we were stating the continuity equation, which is area 1 velocity 1 equals area 2 velocity 2. That is, for instance, the volumetric flow or the volume per unit time remains constant, and this is due to a mass balance. And we were also working with Bernoulli's equation, which is a conservation of the energy, which is pressure 1 plus 1 half of density velocity 1 squared plus density gravity height 1 equals pressure 2 plus 1 half density velocity 2 squared plus density gravity height 2. And each term, 1 half density velocity 1 squared, is the kinetic term. This is also the kinetic term, and density gravity height is the potential energy term. And today we're going to start with the application. So the first application that we have is Venturi's tube. There is any given pipe, for instance, and in the pipe you have a constriction. Then the pipe can go again in the same area. So the transverse area, for instance, the transverse area 1 is higher than the transverse area 2. And if you connect, for instance, a U-tube manometer in each place, then since area 1 is larger than area 2, then it will happen that velocity at point 1, the velocity of the fluid which is flowing at point 1, is going to be, for instance, smaller than the velocity at 2. And given this, then the pressure which is generated at point 1 is going to be larger than pressure generated at point 2, so that if you have any given fluid, for instance, let's suppose we have mercury somewhere here, and this is happening, then what is going to happen is there is going to be a difference in height in this manometer, and due to the difference of pressure, and this difference of height can tell you the difference of pressure. A difference of pressure will tell you the velocity of the fluid. So actually, this Venturi's tube is in order to measure the velocity of a fluid inside a given pipe. That's the reason why you input a constriction and a U-tube in order to obtain a velocity. The second application is Torricelli's principle. And Torricelli's principle is applied to a column that is with certain fluid. It could be water, for instance, and then you have a very huge transverse area at this point. This transverse area is very huge, and then you can state a very small hole at the end of the column. And this area 2 is very small. So area 2 is very small compared to area 1, which means that in continuity's equation, right, this will state that the velocity the velocity at point 1 is very, very small compared to velocity 2, which is, it means it is negligible, so that you can state that velocity 1 tends towards 0. Then of course the fluid will start to move or to drop. Then the level of water will start to decrease, of course, at point 1, but the velocity is very slow compared to the velocity at point 2. So you can actually calculate this velocity using Bernoulli's equation. Pressure at point 1 plus density gravity height 1, and this is height 1, for instance, is going to be equal to pressure 2, the pressure at point 2, plus 1 half of density velocity 1 to the squared. And since we can input here our reference, right, we can neglect that term. The third very useful application is energy conversion. For instance, we can turn the wind which is blowing at a certain speed, and we can have, for instance, a propeller which is, for instance, a windmill, and this wind will start to turn this blade into circles, and we can turn the kinetic energy of this wind into a useful work. This is also a very useful principle, for instance, when you have rivers where there are, for instance, waterfalls, and then you put a turbine downwards, a turbine that it starts to move. It starts to move when, due to the potential energy of the potential and kinetic energy of the fluid, and this happens, for instance, in dams. So the kinetic and potential energies of this river are turned into work, and this is very useful in, for instance, power generation. Just remember that power is going to be a certain work done in a certain time, such that this is in joules per second, which we call watt. Usually we express the power generation in kilowatt or megawatt, and whenever we're talking about energy is joules, but we have another very useful unit that is, for instance, kilowatt per hour or kilowatt hour, which is also an energy unit. The very last exercise, or the very last application, that we have is, for instance, the aerodynamics. We have, for instance, an airplane, and the airplane has, of course, its own weight. Now, this weight has to be counterbalanced for another force which goes upwards, and is not a buoyant force, but is called a lift force. This lift force is counterbalanced with the weight, and of course, if the lift is higher than the weight, then the airplane will start to go upwards. In order to generate this lift, we need another force, which is called the thrust of the plane. And the thrust of the plane is generated, for instance, by any given power machine. It could be a turbine, for instance, that starts to move the airplane. And whenever there is thrust, lift, and weight, then the air that is moving against the airplane will start to generate vortices, and these vortices will start to generate another force that is actually called the drag force, generated by vortices of the air. Now, very interesting, the lift force is generated due to a profile. So, for instance, we have the wing profile, something like this, right? This is the upper part, this is the upper part, and this is the lower part. And the transverse area of the upper part has to be lower than the lower area, than the area of the lower part. This is, of course, of the air, because the air that enters any given point has to travel exactly the same amount of time upwards and downwards in order to reach the exit point. And then, of course, in this situation, the velocity upwards has to be higher than the velocity at the lower part. So, due to continuity equation, the area at the upper part has to be lower than the area at the upper part. And of course, if the velocity upward is higher, then the pressure upwards is going to be lower than the pressure downwards, and this difference in pressure will generate a force that is going to lift up the plane, and this is called the lift force. So remember, we're talking about continuity equation and Bernoulli's equation applications to life. This could be a Venturi tube, this could be a Torricelli's principle, energy conversion, or, for instance, the aerodynamics of an airplane.